Hello, hello, hello. Well, I've got a green light, but my projector's not working. Oh, there we go. Whoa. Yep. Maybe. Whoa, no. All right. How visible is that? Can everyone read the text, my name down there? Some of the other text on the slide is that size. All right. I've got a green light here, so I'm going to assume that's good to go. All right, good afternoon. I'm Daniel Colson. I've worked in IT security for about 9 years on both the sysadmin and security operations sides. I'm a Charlotte area native, and today I'm talking about the methods I've used at my day job to build a scalable, containerized automation processes with minimal headaches, and ones that can be maintained and added to in a mostly standardized way. I'm not claiming that this is the absolute best way to do this, but it's a working setup that I've iterated on a few times. It's currently running and monitoring about 30 different automation processes at my day job, some of those running several times a day. There certainly will be environment-specific things that will need to be different if you want to replicate this elsewhere, but the core principles and methods that this is organized around should be transferable to other environments. And please feel free to ask questions at any point as we go through this. So as an overview, is that text still readable? Okay. All right. As an overview here, if you're in this situation, you probably have a collection of scripted automation processes, or you need to develop or create one, and you want to monitor all of them for errors, be alerted if they fail, and in your case, a dedicated tool or service for this is not an option, either because of monetary, environment, or preference, or other reasons. And you want to be able to easily migrate in case of backup or recovery or server migration cases. So for some context, here's some primary task categories for the automations in my environment. So generating CSV lookup files for Splunk, querying Splunk and using that to send data somewhere else, synchronizing lookups around, retrieving data from services that don't talk to Splunk directly and parsing it, sending it in there. If you're not familiar with Splunk, lookup table files are used kind of like SQL join operations in the queries to look up additional fields based on one field, like a user ID or something, so you can look up more information about that. So we generate lookup files, which are basically just CSV files that get updated to Splunk every morning with information about Active Directory users, workstations and servers, things like that. And just to set expectations here, this is a how-to on building a not too complicated solution for this. I do have a GitHub repo with that I'll provide with what I think are the reusable parts of this. But as previously mentioned, this overall type of solution is likely to need customization for your environment. I'm mostly just providing the methods to build what I think is a good solution. And I give you the it works on my machine guarantee for all this. So my primary goals when building the solution were these 3 M's. modularity, maintainability, and monitoring. I wanted to make sure that these pieces were modular enough to be able to reuse automation code and not have to write very much completely new code for each automation, or even dig code out of one automation to copy paste into another, if possible. I wanted them to be maintainable, so it would be easy for me or others to set up new automations and update the ones we have in a standard way. And I wanted to be able to monitor all of it and be notified when any errors occur, not if, but when. So here's what I ended up using. All the automations run via cron in Docker containers for our Python-based automations or Ansible playbooks. I'm using Docker containers because it makes it easy to keep a consistent collection of dependencies and Python modules that are separate from the ones on the host OS. We keep the files for our automations tracked in Git and backed up to our internal GitLab server. When the automations run, we capture the standard error output from the automation scripts, and if there are errors, they get collected, formatted a bit, and emailed out to my team. If you're unfamiliar, Linux has 3 standard streams for data: standard in for input to a program, standard out for normal output, and standard error for error messages. A little bit of oversimplification there, but for example, if a Python script encounters an error, throws an exception, the text of that exception message gets sent through the standard error stream. And standard out and standard error show up the same way in the command prompt, but they are separate and can be separated, and in this case, redirected to a file. In addition to the standard error capturing, the automation scripts are written to include some error handling for conditions that we can anticipate and correct for without the process failing. And where reasonable, like where an output file is generated, we have output validation either in the automation script itself or an additional script that will check for the output for expected results. And that can be as simple as, is the file empty or not? If we're expecting 500 lines of output on this CSV file, for example, then having it blank is not what we're expecting. And you can get more granular with that, of course, and say I want it to be over 100 lines, or this field should be this value or in this range, things like that. And we do have some monitoring along those lines as well for certain automations. So I did mention that I'm using both Docker and Ansible for automations, and I'll go over the Docker-specific things first. When I started building this, I had a Docker file for each automation to build a Docker image specific to each automation. I found that this takes up unnecessary disk space and is confusing with lots of unique images, and a lot of the tasks we were automating were actually in similar categories, doing the same kind of things, but just in different ways or getting different data. So I now only have 4 or 5 common or generic images that work for most of our automations. For example, I have an image built for automations that send the results of a SQL query to a CSV file, and another for LDAP and HTTP API interactions, things like that. Some of these also, like the HTTP API one, also have things like the SplunkLib Python module for interacting with Splunk, since that's somewhat common for our automations. So to tie this back to those 3 M's, using a few generic images here is more maintainable and modular. Some exceptions will apply to this, of course. I do have a couple of automations that are a bit more complex or just need certain dependencies, so I do have specific custom images built for those. But most of the automations, for my use case at least, work fine running in one of those 4 or 5 generic images. The other major part of the way that I use Docker containers, which enables using those generic images, is that I don't bake the automation files into the image. If you've built your own Docker images before, you'll know that you can use the copy or add instructions in the Docker file to include outside files into the image, so it's all a nice, fully self-contained package. It'll just run anywhere. If you've got a full CI pipeline set up where those images are automatically rebuilt when you commit changes to the code, great, just use that. But if you don't, and you want an uncomplicated way to be able to change code anytime and have it apply without any extra steps, go with volume mounts or bind mounts, depending on which documentation you read. It's using Linux bind mounts under the hood. But if you volume mount the automation folder, where you have your files for the automation, into the container at runtime, so that the folder on your host system with the automation files is also accessible at a specified path in the container, you can update the files without needing to rebuild the image. So here's an example command for that. This is split into multiple lines for readability, but it's all one command line. So this runs the container and removes it when it's finished with a --rm. And volume mounts the host folder / path to this automation into the container at / this automation. And then we have the name of the image to use and the command to run inside the container, which in this case is / this automation / start.sh. More on that in a moment. In rereading the documentation on this as well, while I was building this presentation, apparently there's a newer version of --mount, or a newer option of --mount, which is a slightly different syntax that's supposedly better than using -v here, but either one will work. So the command that I run inside the Docker container, which is the starting point for the automation, is one named start.sh. You can name this whatever you want. That's just what I decided to standardize on. This is kind of a manager script that is started with a cron job or another method, and it runs started using that docker run command we just saw that executes start.sh. This script does any environment setup that's needed. For example, for me, it clears the error log file as well, so it'll be empty and ready to store any collected and formatted error content that'll be sent out and in notifications. It next executes the automation scripts, and this is just doing whatever you need your automation to do, and it's redirecting any standard error output to a file. And lastly, it executes the monitoring scripts to collect, format, and alert on any errors that were added to the error logs when the scripts ran. So here's an example of what my start scripts will look like. It's kind of a bare bones view, but in this case, it CDs to / this automation inside the container. This is all running inside the container. And so the CD there is just to be certain we're in the folder inside the container for automation, and so relative paths will work. We might not actually have to have that, but and then we echo a blank to the errors.log file. That's just to clear it out for be ready for formatted messages, in my case. Then we have a Python line that runs automation.py and uses > symbol to redirect that out to a file. That's how you would access the standard error stream. You can also use > to redirect the standard out. And you can use both of those at the same time. And I've standardized on redirecting out to automation name.err for my error files. Then we next have a line that runs the standard error mon scripts. This is just my set of error handling scripts, which I'll get into more detail how those work in a bit. That's the piece that I have a GitHub repo for. I do recommend keeping your configuration for error handling and monitoring, like the target notification email, a friendly automation name instead of this automation. It's like this automation that does this or something. As well as some help text to help debug the automation to show people what might have happened. I'd recommend having those kind of things in like a configuration file that your monitoring scripts read in. Instead of writing it into the monitoring script, just so that you can copy the monitoring scripts over without changing anything to a new automation, and then you just edit your new configuration file instead of going and editing the script each time, which ties into those 3 M's as the modularity part. So here's the process that the monitoring scripts run, just to have it kind of a visual flow. So we read the notification configuration from the configuration file to let us know how to notify people if anything happens. And then find and collect any errors from the .err files and build a nicely formatted message. Mine uses HTML formatting from those ERR files. And finally collect those errors, build the nicely formatted message, and finally send out a notification if we found anything. So here's an example of an error email that I would receive from one of my automations. The items highlighted here in red are read by the monitoring scripts from the configuration file in the automation folder. So that's the destination email, the friendly automation name in the subject, and then some help text to assist with the debugging. So this automation depends on a connection to whatever. Check that first. And that Python traceback error message there was found in the automation.py.err file by the monitoring scripts. So it's pulling it from there and building this into the message. So this way, we have a subject that tells you what automation this came from. We have the script, the specific script that it came from, the actual error message, and a way to help with debugging it. Sometimes we might not just have automation.py, we might have automation 1, automation 2, automation 3, whatever. So here's some variations of the process of running that automation with start.sh through a Docker container with cron. I've experimented with these. I may go with the second option here in the future, but just to address possible questions on this, if you could add a docker compose.yml file that does create yet another file to track and manage. So depending on the technical capabilities of the other team members who may maintain this too, it could just be simpler to stick with docker run commands in cron, as opposed to putting them into a compose file. Because that does shorten it a bit, makes it a little more concise, but adds some abstraction. The other option is you could move them into the start.sh script instead of having them in cron lines. I haven't fully tested this in my environment yet to be sure I haven't overlooked some issue, but initial results are promising. And you can have the cron job just run the start.sh script directly in this case, because the start script checks to see if it's in a container or not. And if it's not, it runs that Docker command. And if it is already in, then it runs the rest of the automation since it's already running inside the container. Option 2, yes, I like option 2 much better. Right now, I do still have just the cron job has the Docker command in it right now. It's simple, but I think this will be better in the long run to be able to track that Docker command in Git. Yeah, scalable. So here's an overview of the process that happens when the automation runs. The cron job triggers and runs the Docker container. The container starts, volume mounts in our automation files, and runs the start.sh script. It starts everything. The start script sets things up, executes the automation processes, redirecting standard error for monitoring and alerting. Then the automation scripts perform their tasks. That's kind of in the previous step too, I guess. And then the monitoring scripts check for any errors that were generated and notify us. So let's talk about the coding standards or methodology that I'm using for writing the code for these automations. This will hopefully not be as boring as the title might make it sound. We'll tie these as well to those 3 M's also. So if you're writing an automation process to interact with an internal service, or even an external one, if you have specific use cases and features you'll be using on that, take the time to write a little bit more code and make it into a module that you can just import into your scripts. I recently wrote a module to interact with certain features of an Akamai API to make it easier to reuse those features in our use cases. Just only writing the script that uses the API would have been slightly faster, but we're going to be using those API features in possibly several other different automations soon, and modularizing that enables rapid reuse, like building those new automations faster and easier. Am I creating a module or a package? I'm currently doing a module just because I don't have that much complexity to make a whole package, but you could totally do that. So I also wrote a short Python module a while back that contains one function. Takes in a few parameters. It makes an HTTP call to retrieve the password for the specified service account from an internal password vault service, and there's more security around it than just an API call. And then it checks to see if there were any errors and retries if necessary before returning the result. It's like 10 lines of code. I could have just copy-pasted this to any new automation that needed this, but having it in its own module that I can just import into whatever automation I need reduces code complexity, makes it easier to update and apply to all automations that use it later, does it in a standard way as well. And it's easier than going and editing each automation's code, potentially having some of those updated, not others, or implemented differently in certain automations. You can be sure that it's the same. It's working the same in all of the automations. And it's just way better in the long term for maintainability, there's that M, and ease of building new automations. And this small Python module is used by most of the automations that we run. We just mentioned maintainability as a benefit of modularity, including that you may only need to update one file instead of digging around to manually update multiple different files. Another thing I'm doing to improve maintainability is separation of data and code. So this is often taught as a secure coding practice, as well to help prevent malicious code injection. It's also a good practice for maintainability, because if you have long like SQL queries, Splunk queries, LDAP queries, whatever, or things like that that your scripts use, those are probably going to be needed to be updated at some point, either whether that's because of changes in data format, systems and services changing, or just the needs of the automation changing. It's easier to update a separate file that contains your SQL query than to go edit the query inside a Python script and keep any quotes or escape sequences intact, stuff like that. It's harder to mess up. It also allows for someone else who knows SQL, to stick with that example, to update the query for an automation without even knowing anything about Python or whatever scripting language you're using. So you can have your SQL guy go and update this file, or give you the file to update, and they don't have to deal with like editing the scripts. Another part of this separation you can do is inside the script itself. Host names, URLs, usernames, things like that almost certainly will change at some point and need to be updated. If they're written into your script, define them as variables near the top of your script, and make it easier to find and update them later. Don't just put them into your connection string or whatever, put them all at the top of the script, or close to it at least. Lastly, take the time to write good comments in your code on what's going on, how the logic works. This is both for your future self when you come back to it later and go, what was I thinking when I wrote this? And for anyone else who maintains it as well. There's a quote that goes, always program as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. On that note, I would recommend putting at least your name in the top of your automation script, so if there's a question about how something works, later the right person can be contacted. Git commit logs might also be good enough for this too, if you have that. So on to the third M, monitoring. I'm monitoring for errors from my automations in 3 different ways. In the script itself, with error handling and logging, with a process that runs the script using that standard error redirection, and in the start.sh file, and the monitoring scripts that collect that, and either with a service that receives the output, like Splunk, like we're sending a bunch of CSV files to Splunk in my case, or an additional output validation script, depending on the use case. From what I can tell, this combination of monitoring should, that's the it works on my machine guarantee again, should handle all known and unknown ways that the script could fail if it's implemented properly. So to look at these in more detail, we'll start with the monitoring in the script. So use try-catch blocks, or the equivalent in your preferred language, to catch and either handle or raise exceptions for errors in possible conditions that you can predict. If you have a try-catch block and then you have to raise an exception because your error handling didn't work, then at least your monitoring will notify you exactly what happened there. And this is something like a failed HTTP request in the event of server or network outages. You know that could happen, so you can put a try-catch block around that. This can also include just status messages that get sent to a log file, centralized logging, whatever, that just state like where in the process the automation is at the time, and maybe how many items it's processed, if that's what you're doing. Things like that that can be possibly used to like debug or confirm the working status. For unknown errors we can't necessarily anticipate. This is the part that I have a GitHub repo for with example scripts you can use. We can use the standard error capturing method we mentioned earlier to redirect all standard error output from runtime errors to a file that the monitoring scripts can check. This will catch things like unhandled connection errors, invalid, missing, malformed data that is received that the script can't handle. Handles accidental changes to file permissions in the automation folder that prevent required files from being opened or written to, all of which I've seen over the course of building out this automation solution. So the last section of monitoring, output validation. This is the last line of error checking. So if your automation is supposed to, for instance, output some data to a file or another service, and all the automation steps work without errors, everything works fine, but the resulting data isn't what it's supposed to be. You end up with that blank file, maybe. That's a problem, and we need one more layer of monitoring to be able to catch that. So if the automation generated some files that are going to be sent out elsewhere, you can do things like check if they're empty first. I use Ansible to copy some generated CSV files out to Splunk, and the Ansible playbook for that has a check to be sure that the new file isn't empty before it overwrites the old file. You can also use some data validation scripts that run after the main automation and perform whatever checks you have to confirm that that's the proper output. As I mentioned earlier, since some of my automations involve sending data to Splunk or making updates to items in Splunk, I can use Splunk itself to validate that the data it's received is valid. Create a Splunk search, an alert on that, and if it doesn't match what it's supposed to, it can alert me. Some exceptions may apply with this output validation. So, cases where you interact with an external web service API, and you may not be able to validate the output on the remote side. So validation checks have to happen in the script itself there. So let's go back to how the automations are set up and look at Ansible-based automations. When I first started building out this setup, I had specific Ansible copy commands like that first line there in the cron jobs for the automation for copying the generated CSV files out to the Splunk servers. Eventually we built an automation that generated like 4 or 5 different files to copy out, and that got to be a lot of lines to manage in the cron file. So I moved them into Ansible playbooks. This makes the command in the cron job simpler. That second line there now, we're just referencing a playbook file and running that. And it keeps our automation configuration, the files to copy and the paths that they're supposed to go to, in with the automation files so that we can keep them tracked in our Git repo. We also needed to use playbooks anyway for some other Ansible-based automations that needed more than just copying files from one location to another. We have automations that do things like make sure a list of production Splunk apps are properly cloned from Git onto the Splunk deployer servers, stuff like that. You could have any Ansible playbooks that are associated with the Dockerized automation, either run from the same cron job or have start.sh trigger them depending on your environment and the way your Ansible is set up. Because we have automations that are like a Docker component that generates some files and then Ansible that copies the files out. So here's an example of the most common type of Ansible automation in my environment. This is a task section from the playbook. And this uses the copy module to take 3 CSV files that were generated from our automation process and send them out to a remote server, like a Splunk app folder in our case. Ansible will loop over that list of 3 CSV files and template their names in to the source and dest paths there. So we talked about monitoring for the Docker automations. So monitoring for Ansible automations and doing that with callback plugins, which can be used to send logs to other services from Ansible or modify how the output is formatted and displayed. In my setup, I've got the Splunk callback plugin set up so that all the Ansible playbook runs will have their logs and results sent to Splunk automatically. And from there, that lets me track and alert on playbook errors, confirm that everything is working as expected with a dashboard showing the status and activity of each of them, and then have an alert there that if anything fails, it'll send me a summary email of that. There's also several callback plugins available for things other than Splunk if you have something else and you want to send your logs to that. So, as I mentioned, in my case, primary output for automations is Splunk. So I've set up a dashboard to track Ansible errors and Docker runs and alert my team if something's not working right. I'm currently using email notifications, but obviously you can send notifications to Microsoft Teams, Slack, Matrix, whatever, or ticketing platform, notification service, whatever you're able to integrate. In addition to the email alerts for Ansible failures, I've got an alert set up also for some data validation cases like empty lookup files. So we have some automation, I kind of mentioned this earlier, but there's some automations that are Docker only, some Ansible only, and some that use both. When it's both, we keep all the files, the Python scripts, the YAML files, all together in the same automation folder. Both kinds are started by cron jobs, and we'll share a cron job if they're part of the same automation. Just keep both those commands in there. So let's take a look at how all these files are tracked and stored. All our automations are stored in one Git repository in individual folders. Most of our automations aren't big enough to warrant their own Git repos, and that would add complexity for our setup. We keep a README file in the repo up to date with basic information about all the automations, like what the name of the cron job is, a short description of the purpose of the automation, and a list of any output files that it's supposed to generate. I do keep my custom generic Docker files and the Python modules I've made in separate Git repos, though, because they're not directly part of the automations. And the automations with their own specific Docker images have a Docker file in the automation folder. So it's all tracked by Git. So looking at how to set up the Git repo. Depending on how many users you're going to have working with these automations and their level of experience with Git, you may need to adjust your approach to this. In my environment, not everyone has enough experience with Git to handle a full, proper Git repo setup with like feature branches and every user having their own local copy of the branch to keep up to date before pushing commits and merges, stuff like that. And for our purposes, we don't really need a complicated setup. We're mostly using this Git repo for change tracking and backup and reference on our internal GitLab instance. So when we make changes, we just go ahead and push the commits. We don't really make commits via the GitLab web UI very often. That would have to be pulled back to the automation server. So, and for us, a single shared branch that's located on the automation server makes things simpler and mostly prevents merge conflicts. Again, this is one of those cases where your environment may differ quite a bit. This is just how we've got it set up for ours. If you remember the list of goals I had back at the beginning, the last item was being able to easily migrate to another server in case of hardware upgrades or for backup and recovery purposes. We've migrated our whole setup once before. The VM that our server was running on had a version of RHEL that was older, being phased out. So we ended up getting a new VM entirely. Because almost everything was in our Git repos, once we got our access to the new server sorted out, all we had to do was clone a few repos from our GitLab, rebuild the Docker images, and copy the cron jobs over. And that was pretty much it, to migrate the whole thing to another server. So admittedly, the cron jobs are currently the weak part of this, since they're in several files in /etc/cron.d, one for each automation and not in a Git repo. But many of our automations just need to run once in the morning. And for the ones that have specific timing requirements, like once every hour, once every 5 minutes, or whatever, that's documented elsewhere. And we could reconstruct the cron job contents, runtimes from Splunk logs as well if we had to. So let's do a short overview on some of the major concepts we've been looking at for building this. So we're focusing on modularity, maintainability, and monitoring. We can build Docker images for major task categories, so only a few images are needed, and we can volume out the files that we need into it. We're using a manager script to execute the task scripts and capture those errors. And then we have monitoring both inside and outside the automation, as well as output validation where it makes sense to have it. Future improvements. So there are some things I'm either testing or considering for the future of this setup. I'm considering moving toward the long Docker run commands from the cron job to the start.sh script, like I mentioned earlier, where the script would check, am I in the container already or not? Do I need to run that? And that would keep more of the configuration, the Docker run command, tracked in the Git repo. And the only reason I didn't present that as part of my current solution is that it's slightly more complicated, and I haven't fully tested to make sure there's some issue I haven't considered yet with that approach. There's a neat tool called Cookie Cutter that takes file and folder templates that you create, lets you interactively fill in the template variables to set up a new project of the type that you've created a template for. This would help in making the creation of automations faster and more standardized or controlled because there's less manual copy, paste, edit processes happening. I've got this mostly working now, actually. I think there's a few cases for some of our automations I need to account for, but it's not too difficult to set up. Let's see here. I want to find an alternative to having lots of cron job files, or at least a better way to track them better. Some method for storing and tracking those so they're not just a bunch of individual files in etccron.d. And then volume mounting the current custom Python module. So those custom Python modules that I mentioned, right now they're just like copied into each of those automations. If we need to update them, we just recopy them all back. It's not a lot of effort, but a better way would be to, a potentially cleaner way would be to allow every automation to use the exact same file. So you'd use another volume mount to mount a read-only volume mount to bring that folder of Python modules into your container at runtime, and then set the Python path environment variable in the start.sh script so they can just be imported. I have tested something like that. Have you used that before? Okay. Nice. Yeah, I think that's definitely the way to go forward, to keep things separated so you don't have even that much copy and paste around. Yeah. Keeps modules on the same versions. Yep. So that's kind of similar to the first item in that it's more complicated. I haven't fully tested it yet, but it's definitely a way forward to go. And then monitoring and notification of recovery after previous errors. So this will be notifying not just about automation errors, but success after a failure. So for automations that run many times a day, if an error happens, it would be nice to see confirmation that it resolved itself later instead of only seeing the error emails in your inbox. I'll probably implement this in Splunk, but that's something I want to do going forward too. There's some contact methods for me. I'm also in the SouthEast LinuxFest matrix chat, and that there is the GitHub repo for those scripts. That includes some example, like a template start.sh and the monitoring scripts, things like that. So, any questions? The automation code is all tracked in Git, so it's not like a specific like version number or something, but it's all tracked as Git commits. Then the container image, I actually don't update the container images very often because they don't. I'm not too worried about the security aspect of that because they're not like hosting anything. They're only like connecting to internal stuff. Those aren't really tracked. Well, that's not true. The Docker files for them are tracked in Git. So. You're talking about volume mounting the start.sh script in? Right. As far as the security implications of that, I guess it's set up so that only our team can access that code repository or that server. So network security is beyond my position. So I'm not too worried about the security implications of it in our environment anyway. So. Right. Right. Auditability. You could Ansible to bootstrap the cron files. I mean, setting those up, having those tracked in a Git repo. Yeah, that's true. That might be a good option. Yeah. Okay. Yeah, makes sense. Yeah. Getting the line number of the script that had an error. I mean, yeah. Right. Okay. Any other questions? All right. Well, thank you for coming.